Hello everyone, welcome back to our channel Hi-Fi Study for You. Today we will be going to start our physics chapter that is very important for class 9, and that is the basics of physics, that is the motion. Okay, we will start from the basics to the end. So let's start with the motion. So firstly, the first thing which comes to our mind is that what is this motion? So firstly, let's take two things. Let's take, you all know observers, right? Observer and object. Let's suppose there is an observer here. This is an observer. There is an object. This is a kind of object. Okay, let's suppose this is point A, this is point B. What I'm trying to tell you that when between observer and object, if the distance with respect to time changes, then the observer will say that object is in the motion. Okay, got it? So what is motion? Motion is when a body changes position with respect to time, that is called motion. Okay, and the opposite, rest, what is it? If a body doesn't change its position with respect to time, it's called the rest. Okay, so there is one more topic, rest. When object doesn't change its position with respect to time, or in real words, in physics it doesn't care that who is really moving. Is observer moving? Is object moving? It only cares that is distance between the observer and the object changes, that's the motion. Got it? When distance between them changes. Now, the second thing is that we all knew and we all studied in our textbook, there is written that motion and rest are relative terms. Why motion and rest are relative terms? A very important thing, and also came in exams, that why motion and rest are relative terms. So why these both are relative terms? Why these both are related or relative terms? They are relative terms because for the same observer, for the same time, for the same object, there could be different arguments about the same object. One can say that that object is in motion, and one can say that that same object is in rest. I will explain you, don't worry. So what happens that, let's suppose there are two observers. Let me first rub this so that you can understand clearly. Alright, this is our object. This is the observer A. This is observer C. This is also observer. This is observer C. What is happening? Both of these are watching the same object at same time, but different observers. So what is happening? If the distance between this is changing only for observer A. Let's suppose the observer A is sitting in the car or any train. The observer A is moving, so the distance between the object and observer A is changing, but for the same object and observer for C is not changing. Means motion and rest are relative terms. For the same time, for same object, there could be different arguments that that object is in motion, that is in rest. That's why motion and rest, you say, are relative terms. Got it? Now let's move further and talk about few more types of motion. Very important, you should keep a track of all of these. So types of motion, there are actually many types of motions. We will study what we have to. The first type of motion we have is translatory motion. So what is translatory motion? Translatory motion is a type of motion when object or observer, anything, object is moving from a point A to a point B without change in its orientation. Orientation means side. Let's suppose I am here and I walk like this. Then my side is to yours, means this right hand will never change to left. This is called orientation, means same side should be facing to the same place. Okay, the orientation doesn't change in translatory. It's a type of motion where object moves from a point to another point without changing orientation. Can you give me examples? Hey, you should, because when we move in the straight path is the translatory motion, right? Or also for curvilinear path, if we don't change the orientation, it's also translatory. Okay, now translatory have two more types, rectilinear and curvilinear. We just talk about them. Okay, rectilinear is the motion where we move in a straight path, that's rectilinear. And the second type is curvilinear, when the path could be a curve, that's the type of translatory motion. Now when we have the circular motion, the term also gives us hint that the path is of circle. Okay, when we move in circular path, for examples, when are very famous, when athletes run around the circular path, that's what the circular motion is. And next we have rotational motion. And you all have heard, as Earth rotates around its axis. Axis means at a point. Let's suppose this is our Earth, okay, and this is the axis. Axis means a point, right? Or anything, you can take a piece or anything. When we move and rotate, it's about this axis or at a particular point. That's the rotational motion. Okay, we have periodic motion. So periodic motion we should understand. So here is periodic motion. Periodic motion is a type of motion when that particular action repeats after a particular time period, after same time period. You have seen the motion of a simple pendulum which is suspended like this. It moves as this is the watch and this is the pendulum. Let's suppose it go like this, come back like this. This is the main position. This here is the main position. This here go in both directions. That's what the pendulum is and the periodic motion. These are the types of motion. And now begins our journey. Today, now we are going to talk about few more basic important terms related to motion. So let's move further for them. So the first main term is distance and other is displacement. They're both very similar, very different also. So let's talk about them. The first is distance. We all know this. Just we are giving them particular names and they became like very new. So distance is what? How far is it? Let's suppose there is a point A to a point B. Then how far this distance is, I'm using the term distance for the definition. So distance means when the length of the actual path. Now what is actual path here? Actual path means is a kind of path where you walk. Okay, let's suppose you are walking from this point to that point. So your path is this straight line. So the length of this straight line is your distance. Got it? Distance is the length of the actual path length which is covered by the body in a particular time. You can specify this. That's what distance is. Let's move and talk about displacement. Displacement. Okay. Now what is displacement? Yes, we also know that displacement is the shortest path length. Now let's suppose a body moves from this point A and moves like this, goes up, move like this and goes up to this point. Okay, now I ask you, what is the displacement? Displacement you all know is the shortest path length, and you also know that shortest path length is the straight lines connecting two points. That's your displacement. So should I connect this? Yes. When we connect this point, it's not a straight line but just exact a straight line will make the displacement of this particular motion which we have covered. We also solve questions based on this. So displacement is the shortest path length between the 2 points or the two, like, of the distance which we are covering at a particular kind of path which we have taken. That's the distance and displacement. Now tell me, what is distance? Distance is scalar or vector? Okay, first let's talk about these quantities. What are they and how can we get to know that whether a quantity is scalar or vector? So in physics there are two kinds of quantities, that are scalar and vector. Scalar quantity is those kinds of quantities which doesn't require direction for the specification, or for the to describe them we don't need direction at all. We just need its magnitude. Now first, what is magnitude? Now magnitude is just the number. Let's suppose I'm giving you 5 meter per second. This is the speed simply. This 5 here is the magnitude, and meter per second is the unit of the speed. Got it? This is the magnitude. So scalar quantity only contain the magnitude. They don't require direction. Second type of quantity is vector quantities. So what are vector quantities? Those quantities which need magnitude obviously, but they also need direction. They don't need both magnitude as well as direction. We will talk about the examples. So they needs direction. They needs direction, and this don't need direction. This is the main difference. Okay, so scalar quantities, talking about temperature, right? 10 degrees Celsius, 50 degrees Celsius, 30 degrees Celsius. Does you have to tell in which direction the temperature is? No, right? You just have to tell the magnitude of the particular thing. And for example, the speed, let's say 50 kilometers. Did you have to tell the direction of the path? No. So that's what the scalar quantity is. For time also don't need direction at all. That's what the scalar quantity. Vector quantities, we will talk about them, like velocities, acceleration, displacement. These all are vector quantities because they need direction to specify them. Okay, that's what vector quantity is. Now let's move further and talk about the main part, and which is, okay, then we have, after distance and displacement, we will talk about velocity. So we have here velocity. So what is velocity? Now we told that distance is the actual path length, displacement is the shortest path between final and initial position. Now what is velocity? Velocity is actually the rate of change of displacement. Now firstly let me give the formula of the velocity. That is, I am representing the displacement by d, or in physics we should represent it by s. That's much better. So s by t is the velocity. S by t, right? So s by t is velocity. Now always keep in mind, whenever you have any formula, then you should keep in mind, if in the denominator you got time, the first thing which brightens in our mind is that this thing must be a rate of something which is written in the numerator. Alright. Now in this case it is the rate of change of s. S is what? Displacement. So velocity is the rate of change of displacement. By formula we can write the definition of this. That's what the velocity is. Okay. This is our velocity. Now with this velocity, a similar term also came, that's the speed. Okay. That's the speed. Now speed, as we all know, is like, we had taken example like 5 meter per second, means in a particular second, in 1 second we have covered 5 meters. What is it? It's distance upon time. It's also, we also write distance as s. So s by t is also s by t. So can you write the formula? Yes, it's the rate of change of distance which is written in the numerator. Whenever you have the time in the denominator, it's always a rate. That's what, and in this case, rate is not like price, rate is speed. Okay, that's what velocity and speed is. One more quantity which we get to know is average velocity, average speed. It's very simple. In average speed, what we have is total distance by total time. Let's write this: total distance upon total time. And for the same, just we have to replace distance by displacement. We got average velocity, that is total displacement upon total time taken for that particular journey. Okay, now let's move further and talk about one more and basic important quantity, that is the acceleration. Yes, that is the acceleration. Now what is acceleration? Acceleration is actually the rate of change of velocity. Okay, we know that rate of change of distance is speed, rate of change of displacement is velocity, rate of change of velocity is acceleration. Now what is acceleration? Whenever you hear the term acceleration, you should get to know like speed up. We also have in our cars and in mainly motorcycles the accelerate. Accelerate means speeding faster. We also have the opposite term which we call retardation, so we'll get to that. Okay, so acceleration, when you put acceleration not retardation, it's always positive, it's negative. Retardation is negative or deceleration. So acceleration, we got to know that rate of change of velocity. What is rate of change of velocity? Change in velocity in particular time means change in velocity upon time is what acceleration is. So we will write that change in velocity upon time. That's what acceleration is. And retardation is just its opposite. When acceleration is negative, we call it retardation or deceleration. Means in future there are much possibilities to object to come in the rest. Got it? Now change in velocity is also like final position or mainly that final velocity minus initial velocity upon time. We will get to these signs, all of these. So for acceleration we denote by A. We denote it by A, small a. Then for time we denote it by T, you all know. Okay, for time we know T. For final velocity we have V. This is our final velocity. This is our final velocity. This is our initial velocity, U. Get it? This is V is final velocity, U is initial velocity, T is time, acceleration is A. This is what some symbols. Now let's move to major part, and that is the equations of motion, and we also talk about this derivation. Okay. So equations of motion. Now firstly, tell me what is acceleration? I just told you. Acceleration is the rate of change of velocity. For rate, it's upon time, means change in velocity upon time. Very good. Now acceleration means A is equals to final velocity, which is V, minus initial velocity, which is U, upon time, T. This is V minus U upon T. Now if you look at this and if you do some simplifications here, then you go to know that after cross multiplying this, you can get that AT is equals to V minus U. AT is equals to V minus U. And if you want to get the value of V, you can write, can you find? Yes, V equals U plus AT. Yes, that is what our first equation of motion, which tells that the final velocity will be equal to initial velocity plus acceleration into time, which is V equals U plus AT, which is our first equation of motion. Okay, now keep this in mind let's move and try to derive the second equation of motion. We have derived the first. Let's move to the second equation. Okay, so second equation. Now see the first equation, that is b equals u plus at. Can you find this t here? If t is unknown, all of these are given. Can you find this t? Yes. T equals v minus u upon a. Yes. So this keep this t in the mind. Let's try to find the second equation. Now in the second equation, we need to find the distance. Okay, we need to find the distance, and I told you distance is denoted by s. So s equals, now s is what? Distance is what? We know distance is velocity or speed into time. We also know this from our early classes, that distance is equals to speed into time, right? Speed into time. So in this case, speed is also velocity, right? And time t. So s means distance is equal to speed is velocity. What is the value of average velocity? We find that it is v minus u upon t. But in the case of uniform acceleration is where the motion in the straight line, and that's what a kind of uniform acceleration, where these keep in the constant, it doesn't change, it's keep uniform. So when the s is equals to velocity, which we have one more formula, that is v plus u by 2. That is one more that we will get for the third. Now we know that velocity is equal to v minus u upon t. So we will write v minus u upon t, and time we will write t. Right? This is what our second equation. If we solve this further, we will got that here, that v, if we put the value of v from the first equation, that is s equals u plus at plus now here, if we put this value here, which is the velocity, that v plus u by 2, so we will use v plus u by 2. Okay, now v plus u, we have put in the value of v, that is u plus at, then u left plus u by 2, then t. Less space here, so we will rub this all. So what was we have find, that s equals u plus at plus u by 2 into t, right? This was what we have find. So s equals 2u plus at square upon 2. 2 to 2 cancel, then we got s equal u plus at square. And now here we also know that here we have the s equals u plus half at square, which is our second equation of motion. Okay, that is s equals ut plus half at square, which is distance is equals to initial velocity plus half acceleration time square. That is our second equation of motion. Let's move and find the third equation of motion. Now, we know that third equation of motion is v square minus u square equals to as. Or in other terms, we also write v square is equals to 2as plus u square. Right? That is what the third equation of motion tells us. Now, to find this, we have to put the value of t in this case. So, the same manner we have to find the distance. So, s equals to v plus u by 2, which is the velocity. Time in this case is, we have find v minus u upon a, right? From the first equation of motion, no? So, this is the time, this is the velocity. Simplifying this, get our answer. S will be equal. So now this reminds me identity, that A plus B, A minus B, so it will got V square minus U square upon 2A. Right. Now cross multiplying this, you will got 2AS equals U square minus V square minus U square, which is our third equation of motion. That is V square minus U square equals 2AS. This is our third equation of motion. We have found all these three equations of motion. Now, this is our whole equations of motion and about motion, and we will also solve some numericals based on this in our next video. So till then, stay safe, keep learning, and thank you.